Part Programming Fundamentals in CNC Machine. Myself, Dr. B. Suresh Kumar, Department of Mechanical Engineering, K. Ramakrishnan College of Technology, Tiruchirappalli. Here, why we need part programming in metal cutting? Metal cutting is the machining operations to remove the unwanted materials on the required workpiece material, which is known as machining. Yesterday I told you what is the meaning of machining operation. Why we need part programming? The parts are manufactured with the manufacturing industries as like job production, batch production, and the continuous production, and then mass production. So different production processes are available in manufacturing industries. In that we can produce the product with a high quality manner and with high productivity, which is the huge task available manufacturing industries aim. So this part programming is helpful for produce the product with the highest productivity and with the high quality components. Yes, why not with the already available central lathe? Yes, it is available, but I can show you with the video. The instructions are given by thread chart. For example, if I want to produce one metric 1 mm pitch, means I can utilize the tumbler gear that available with the central lathe. In tumbler gear there is A, B, C, D gear train available. In that for 1 mm pitch I can choose for A there is 40 teeth gear wheel, and B gear wheel I can select 60 gear teeth, and then C gear wheel there should be a 40 gear teeth. After that there is D gear wheel available. In that I can choose 127 number of teeth. Based on these instructions I arrange the gear train. Based on that arranged gear train I can get the automatic motion with the normal mechanized central lathe, traditional central lathe. So I can incorporate some mechanization and automation in central lathe also, but I can give the instructions with the aid of gear train. Now I can show you the functions of yes, this is a central lathe. How can we get the automations for producing the threads on central lathe? See here, the carriage moves on lead screw with some automatic motion. Only operator operates the motor on off, so that the carriage moves towards the chuck and outwards the chucks. Likewise makes, but the automatic motion is created with the available tumbler gear arrangement on left side headstock of central lathe. From that the operator fixed the respective gear wheels, number of gear teeth wheels on the respective place. The top side gear wheel is A, intermittent there is B and C, in lowest there is C. Okay, so there are A, B, C, D, 4 types of gears are needed to create the automatic motion on conventional central lathe. So the operator gives a set of instructions to the lathe machine with the aid of gear train. That for 1 mm pitch metric threads he gave like that. Okay, he arranged A, B, C, D. This D is clamped on machine spindle. B and C are available with the intermittent of gear train, and D is available with the feed shaft of the central lathe. The feed shaft is also called as lead screw. Generally in all central lathe the lead screw are having 4 threads per inch. Here he fixed the ABCD gear train on the central lathe. From this we can get the automatic motion of carriage along with the lathe axis. Lathe axis is the ideal line draw between tailstock and headstock center. From this we can get the lathe axis. So carriage moves along the parallel to the lathe axis, what we drawn between tailstock and headstock. So the operator finally connects the D gear wheel on feed shaft, that is lead screw. These are all general instructions already you studied with the engineering topics, engineering laboratories. Manufacturing technology laboratory is available with your college, so you can read. Already studied these experiments with that laboratory. So now the operator fixes on the respective gear trains. Now he can get the respective motion, that is 1 pitch per thread motion he can get from carriage movement. Okay, now he locked the automatic screw with the lead screw. Yes, he locked the automatic screw so that the manual interruptions are avoided with this action. So now he starts the lead screw or motor prime mover of lathe. So the hand wheel takes automatic motion. From this, the carriage moves parallel to the lathe axis. From this, we can achieve the 1 pitch on workpiece. We can achieve the reverse also with the automatic motion. So these kind of operations are available with the central lathe, yes, which is the feed drive. So how can we connect? If I want 1 metric pitch means I plug A as 40 teeth and in B gear wheel there is 80 teeth and C gear wheel 40 teeth and DA gear wheel is 27 gear teeth. I arrange systematically what we are seeing in this video. A, B, C, D here I arranged. From this I can get the 1 metric pitch on the given workpiece. Likewise, I can get the automatic motion in traditional machining also, but it is not sufficient for achieving the mass production. So, in modern manufacturing industries, moved to automation process with electronic controller as like servo motor and stepper motor, and also we can write the programs on NC tape. The MCU reads that signals and receive the signals from the NC tape and give the instructions to the control unit that are available with the CNC machines. Based on that signals the machine operates. This happens in CNC machines. Okay. Now what happens? What is CNC machine? Why we called as a CNC machine? When we are incorporate the computer console it into the NC machine means those machines are called as computer numerical control machine. So CNC machine always helpful for control machine tools like lathe, milling and grinding operations in modern manufacturing industries by the utilization of computers. In that the computers are utilizes the numerical control. Numerical control means programmable automation in machining is controlled by numbers, letters and symbols. Those things are called as set of instructions that to be incorporated in a machine program. That program is input for machine control unit of CNC machine. So the CNC machine always combination of numerical control and computer console to produce the product. Then how can we convert the drawing to product in CNC machine? This is the important question. If you are getting the engineering degree, you should aware about how do I read the drawing. In first year itself, you may studied about technical drawing or engineering drawing subject with your curriculum. But how can I read the industrial drawings? Yes, this also has some its own procedure as like if you are taking the drawing sheet means you should study name and address of the company who prepared the drawing from the title block. After that they provide part number and description of that part with that drawing title block. After that they specified this part number consumes this material. The second part number consists of this material. Likewise, they provide the data. Not only the material name, they provide quantity and weight of the material also with the drawing nameplates, which is also called as bill of material details, that are available with the engineering drawing. So that material and mass available with the drawing also provided with the A3 sheet, which is called as the drawing, that are all studied with the manufacturing engineer, that available in manufacturing industries. After that, the same drawing prescribed about finish requirement. There are a lot of symbols available. Triangular shape, triangular like symbols are available with that drawing. The drawing tells you what about the finish requirement. Based on that finish requirement, you may choose the process. This process is required turning operation. This process is required grinding operation. Based on that finish requirement available with that drawing, you may choose the finish. You may choose the process. After that, there is general tolerances available. From that, you can select the process. Okay. So tolerances, it may be plus or minus 0.1, plus or minus 0.01, plus or minus 0.02 and plus or minus 0.001 mm. All are available with our machine. For example, if you are consider our lathe, central lathe, the least count of that machine is 0.02 mm per revolution you may get. Okay. From this, we can achieve only 0.02 mm finish. After that, we can achieve 0.001 mm finish with the grinding operation, because all the hand wheels, all the mechanisms are obeys 0.001 mm at least count on grinding machine, so that we can achieve higher accuracy in the grinding operation. Not only this machine tool specification, the cutting tool also plays vital for selecting the proper tolerance for required for specific product. And then projection details. The drawing may give you a two-dimensional data, and also it may give you a three-dimensional data. So that the drawing can be classified it into orthographic projection and then isometric projection. In orthographic projections, you may study the drawing with the two-dimensionally, and then from isometric projection you can read the drawing with the XYZ axis three-dimensionally. After that, scale also they produced with the drawing sheet. If 1:2 means 100 mm is converted in 50 mm, so that you multiplied that dimension it into 2, so that I can get 100 mm from that drawing. So that you should aware about these 8 things for read the drawings. So I read the drawing with the proper manner as per these instructions, and then how can I prepare the program with respect to this drawing study for operating the CNC machine. First, based on the drawing, you should study or determine the machining operations to be performed on that workpiece. After that, second step, decide the machine order. First operation is facing, second operation turning, third operation threading, fourth operation is milling, fifth operation is grinding. Likewise, you decide the machine in order. After that, step 3, do the coordinate and cutting condition calculations. I will tell you the both things. How do we calculate coordinate and how do we calculate cutting condition? Coordinate means there is absolute coordinate available, which means Cartesian coordinates, and then there is spatial coordinate is also available, rectangular coordinate system is also available. I will tell you what are all the coordinate system available with the CNC machining operation, and then how do we calculate the coordinate system. Likewise, I tell you. Then cutting conditions. What are all the cutting conditions? Spindle speed required to operate the spindle of that machine. After that, how can I give the, how much of feed I can give that workpiece material. Likewise, I calculate the cutting conditions of the machine tool. So, cutting condition plays with the spindle speed, feed rate and the depth of cut. After that, I should consider work holding device. Can I fix the workpiece on chuck or otherwise fixture? Likewise, I decide based on that work holding device only I can program the machining operation. Then step 4, considering the cutting tools. What tool I utilized for making the product? It may be a single point cutting tool or it may be a multi-point cutting tool. Likewise, you consider the cutting tools for writing the program. Finally, you consider all the 5 things. After that, you may go through, write the program with the documents. Okay, from this we can operate the machines. Okay, now you are aware about how do we study the drawings and what are all the steps that needed to create the program. After that, input methods. How can we give the input to CNC machine? I can write the program and save it into the flash drive, and also we can store that program into portable external drive, and also we can write the program on CD and then diskette. These 4 input devices are utilized for receive the data for actuate the CNC machine. These data are input to the machine control unit. Based on this program, the CNC machine is operated by the operator. So, these are all the 4 basic important things you should be aware about CNC machine program writing, that are how do I read the drawing, how do I write the program, what are all the consideration I should be considered to write the program, and then what are all the input methods that are available to invoke the commands into the machine. After that, how do I manufacture the product and how do I produce the product with the CNC machine. Now, the class deals with the dimensioning available in CNC machine. Always CNC machine utilizes rectangular coordinates. In that, there is x and y axis available. So, if I draw the x and y axis with the graph sheet, means I can get 4 quadrant as like this diagram. In first quadrant, how can I mention x and y values? Here you see x and y axis are both in positive direction, so that first quadrant I put the point here. So this point in x axis 1, 2, 3 and 0.5 units available with the x axis, so that I can mention here x 3.5, and then y axis there is 1, 2 and then 0.5 unit available with the y axis, so that I mention like y 2.5. Likewise, I mention the coordinate values with the respective quadrant, and you can see here the second quadrant available. How can I fix the xy value? In x axis the same 1, 2, 3. 3 units are available, and in y axis 1, 2 and 2.5. But in this second quadrant, y axis are lying in negative direction, so that x 3 units are available, and in y direction there is minus 2.5 value is available. Likewise, you may give the xy coordinate value in part programming. After that, in behind of this second quadrant, there is third quadrant available. Here you consider the x axis also lying on negative direction and y axis also lying on negative direction, so that I choose the point here. It may be P, okay, it may be called as with the coordinate system x minus 1, 2, 3.5. So x minus 3.5, y 1, 2, 3. So that y also lying in negative direction. So that y minus 3. All are real numbers. Real numbers can be represented with the positive and negative manner. And also fraction number also represented with the real number. And also we can represent the decimal number with the real number basis. And then in behind of first quadrant there is fourth quadrant available. If I want to program with the fourth quadrant means here you see x-axis increment 1 unit and 0.5 x, so that it is are lying in negative direction, so that 1.5 x minus 1.5. But in fourth quadrant the y is available with the positive direction, so that y 1 2 3.5, so that y 3.5. Likewise we can choose the coordinate values from the rectangular coordinate system. Based on this we can give the input to the xy coordinate values on the program. Here I can develop the planar 2D point with xy coordinates. For example, if I consider 3D means spatial 3D point defined with the xyz coordinates. From this coordinate system I can dimension the object, and also I can give the input on the product coordinate values on CNC machine program. And then dimensioning in CNC machine is also follows absolute dimensioning method and incremental dimensioning method, which is here I assume tool position here. After that the tool is moved to the initial point which is touches with the workpiece material, which is 0 point. So the tool is lying in 1,1 inch from the tool position, which is approach point. After that how can I get this tool it into the workpiece? If I utilize absolute programming means this is the origin point, which is 0 for move to all holes, which is the origin point. Based on this origin point only I can write the program. Here I produce 3 holes. The 3 holes are named as the number 1 hole is 1, then second one is 2, and the third one is 3. So how can I program with absolute method? Yes, all the holes are readed from the initial point. Here first hole is lying on 1 because of the origin point, so this is 1. And then absolute programming, the second hole is lying 2 because after one hole it consumes 1 unit, so I add both the thing from origin, so that 1 plus 1 there is 2. And then third hole is lying on another 1 unit which consumes 3 units. Likewise, if I mark the dimensioning on the workpiece means, which is known as absolute programming. Not only absolute programming, another method is also available, which is incremental programming. So we can utilize incremental programming also in programming. What is meant by incremental programming? All dimensions are taken from the previous point. Here you see the tool position is 0, available with the same like absolute programming. After that how can I move that tool? I always read previous point, so here is the 0 point. The for considering first hole, 0 for move to hole to the initial position I consider as a 0. So this point is 0. After that first hole moves with the 1 unit. Then second hole, how can I produce? The first hole position, the program assumes first hole position is 0, so that the movement of second hole also consumes another 1 unit itself, and then third hole another 1 unit. So I won't go for absolute method as like 1 2 3. Here every holes or follows the previous hole, so that 1 1 1 unit. Likewise I can give the command to program, which is known as incremental programming. So these are all the basic things you should aware about write the program. And then how can we locate origin point? Already I told you that the origin point available with the workpiece. Then how can I locate the origin point in CNC machine? In all CNC machine there is lower right corner and lower left corner are available. The two origin points I consider. What is origin point? Where xy axis are intersect with each other, that point is called as origin point. So the origin point is called as two types. One is fixed 0, another one is floating 0. The CNC programmer should aware about what is fixed 0 and what is meant by floating 0. So I will tell you What is fixed 0? The generally the reference point fixed on lower left hand corner of the work table, which is lower left corner. I always consider the reference point from here means I utilize the fixed 0 concept for operating the CNC machine. From this point, all other points are located, which is known as a fixed 0. And then, what is floating 0? I can fix at any convenient point on workpiece also. As like this W point, I can fix a convenient point on work table. So, recent CNC machines are utilized this work coordinate system for varying the coordinates and the dimensions available with the machines. Those two are important in locate origin point in CNC machines, that are fixed 0 and another one is floating 0. And then axis. Now you are aware about what is meant by origin, and also how can I select the origin point, and also how can I give the dimensions with the absolute coordinate system and then incremental dimensioning. Now we came to axis orientation. How can I select the axis orientation in turning center and the milling center. Let's see. The lathe we can utilize with the two axes which are x and z. Based on that x and z orientation, the lathe positions are differentiated. So the lathe are called as rear lathe, front lathe and vertical lathe. Here what is meant by rear lathe? The x and z are both are lying in positive direction. So slant bed lathe is rear lathe. And then x and z are both lying in positive direction, but x is reverse direction. So which is called as front lathe, is similar to our conventional center lathe, what I show you in the initial of this presentation class. Okay, after that, then third one is vertical lathe. Vertical lathe means that entire lathe, horizontal lathe is rotated about 90 degree. From this we can get the vertical dimensions, which is called as vertical lathe. So these kind of axis orientations are utilized in turning center. And then what about the machining center? There are three planes available. The first plane is followed x-axis, the second plane is called as followed as y-axis, and the third plane is followed for z-axis. Here the three planes are available. The first one is xy plane, and the second one is xz plane, and the third one is yz plane. Here what is x-axis? X-axis always deal with the longest dimension available with the table longitudinal direction, and y-axis which is always deals with the shortest dimension, which deals with the saddle cross section, and z-axis always follows spindle rotation, and also which follows the spindle movement available with the machining center. So those things are important, you should aware about, write the programs. And then additional axes are also available, not only x, y and z axis, additional axes are also available, but those axes are followed x, y and z axis. So what are all the axes? X, y, z axes are called as x, y, z means those things are called as primary axes, and the same axes are followed with the UVM. These things are called as the secondary axes. And then the third one is arc center vectors, which is circular axis, which are ijk. We can represent the circular movement interpolation with the ijk, which is also possible with the arc center vectors. And then we can represent rotary axis. The x-axis always follows A, and y-axis always follows B symbols, and the z-axis, z-axis always follows C symbol for representing the z direction rotation. These are all the additional axes are available with the CNC machine. And then now we can move to part programming procedure. What is meant by part program? Let's see. A part program means, now just a minute, I will come and tell you, students. Sorry student, some disturbances are available with the machine shop. That's why I stopped the process and I joined with you. Okay, part programming. What is mean by part programming? A set of instructions given to the CNC for operating the machine is called the program. So the instructions, what are all the set of instructions? The instructions are consist of part geometry information and then cutting condition information. Cutting condition means cutting speed, feed and tools. Likewise, lot of informations are available with the cutting condition. And then third one is cutting tool motion statements, how the tool is moved on the work table, circular interpolation or linear interpolation or otherwise rapid traverse. Likewise, we can give the tool motion statement with the program set of instructions. And then auxiliary function, the fourth one is auxiliary function. Auxiliary function follows coolant on off and spindle directions. Okay, these are all comes with the auxiliary function. Let's see how can we write the program with these four set of instructions. I will tell you. Then CNC program structure. The CNC program have some its own structure, but what are all the components are available with the CNC program is the important thing before writing the programs. First, you should aware about character. Character means smallest unit of CNC program. It can have digit, letter, symbol. Okay, digit means 2500 RPM. Letter means S. S represents the spindle speed. Symbol, the S also, which is symbol. Okay, the diameter symbol, we can utilize diameter symbol for it represent the characters on program. And then word. Word means which is a combination of alphanumerical characters. Each word begins with a capital letter followed by a numeral. Already I showed you with the rectangular coordinate system. In that first quadrant consists of x 3.5, y 3. So the xy are also called as capital letters. Always follows capital letter. The followed by that capital letter xy, we should represent the numbers, numeral 3.53. Likewise, the same thing I told that word. Okay, these are used to represent access positions, feed rate, speed, preparatory commands and miscellaneous functions. What is mean by preparatory command and miscellaneous function, I will tell you. Okay, now you are aware about what is spindle speed, what is mean by feed rate from your lathe itself. Okay, conventional lathe itself. So now further details you need that what is mean by preparatory commands, what is mean by miscellaneous function, I will tell you. And then third one is block. It may contain multiple words sequenced in a logical order of processing. What is block? I will tell you with the example. After that, program. Program comprises of multiple lines of instructions, that is n number of blocks which will be executed by the machine control unit. So these four are fundamental things with the CNC program structure. And then you should aware every program has its command. Okay, own command. Here the NC part program also has its command. So the commands can be classified into two types. One is model commands, another one is non-model commands. So what is mean by model commands? If I give the spindle speed, feed rate commands to that machine means these are all comes under model commands. And also I can give the coolant selection. Okay, coolant on off or tool selection. Likewise, I can give that. Those things are called as model commands. Then what is mean by non-model commands? The tool can wait for further operation and the tool retrieved from the hole. Likewise, I can give the 12 time to that machining operation. These are all comes under non-model commands, which instructs the tool to remain in a given configuration for a given amount of time, which are all comes under non-model commands. And then the structure of an NC program, how it operates the machine, which is the next question. Before writing the program, you should aware about The structure of an NC program. So, NC part program is the series of commands. The series of commands also called as series of blocks. So, these series of commands are input to the machine control unit as a serial manner. So, the machine control units generates the signal based on the series of commands. Based on that signal, the drive units of the machine is controlled by control system that are available with the circuits. Based on that signals from the MCU, the control understands the signal, and based on the specific syntax, that command or input to the controller called block. The block made the machine commands. So from this block, words are arranged within the block is called block format. I will show you what is block format. This block format is called as word sequential format. I will tell you what are all the sequential format available. How can we represent the block in a NC program? I will tell you. Which is the word sequential format, that is also called as the block. These type of n number of blocks are used to create the program. So program always consists of n number of blocks within itself. Based on that generated block, the machine control unit read the program through MCU unit and operates the machines with the control system. Here what is block? In block there is sequence of a format of words available. In that first letter is N. Okay, N3 is available. First alphabetic letter, which is capital letter, followed by numerals, the N3, what I told you in previous, and then G, capital G available. After that, it for 2 is followed by G, and then X, Y, Z, both things are coordinates, and I, J, K, F, S, T, M are available with that block. This block is called as word sequential format. Here, my next question is, what is N? N is represented for sequence number. How many blocks are available with my program? It may be started from N0, it may be ended with N100 or N1000 also. Okay, depending upon where program sequence, operation sequence, he may arrange the sequence number. And then G2 is available. What is G? G is called as preparatory function. How my motion is should be. My tool motion is should be in a linear motion or curvilinear motion. I can represent with this G code. And then X, Y, Z, which are the destination coordinates. How much of axis movement happening with the X axis, and how much of axis motion is to be available with the Y axis, and how much of axis motion available with the Z axis. Likewise, I can give the command on the destination coordinates. It also follows first alphabetic letter, capital letters followed, 1.54 is the numerical letters, so that the numerical letter followed by the alphabetic numbers. With that, I can represent the plus or negative symbols, what I told you in a rectangular coordinate system. The dimensions are lying in first quadrant or lying in third quadrant. Based on that, the quadrant, I can decide the plus or minus symbols that are available with the X, Y, Z coordinates. But I can't give the curvilinear coordinates with the X, Y, Z. The linear motions only I can give. What about the arc motions with that program block means? I can utilize I, J, K. So the another axis, further axis also available with the NC program rather than X, Y, Z, that are Y, J, K. From this I can give the circular motions. I, J, K represents the distance to center of a circle. The IJK represent with the center distance from the circle center. After that, I can represent F. What is mean by F? F represented the feed rate and S represented the spindle speed. So, every block consists of the data with F and S. They always F represented for feed rate, S represented for spindle speed. After that, there is another number is also available, T4. What is T4? In turret, yesterday I showed you a turret. In the turret, there are lot of tool stations available. In that first tool station consists of turning tool, second drilling tool, third boring tool. Means I choose the tool number with this tool code, that is capital T. T4 means fourth tool. It called the fourth tool for further operation. And then final one is M. M code is called as miscellaneous code. Which from this I can start the machine or I can stop the machine, which is known as M. So every block consists of these kind of informations to operate the machine. So common words in CNC program. In previous slide I show you a N, G, X, Y, Z, I, J, K, S, F, S, T, M. Likewise I told you here what is code. Here you see first is N, so N is called as N code, G is called as G code. Likewise different code we are utilizing. And what is N code? N code always represented the sequence number. It is used to identify each block within an NC program. So I can utilize n number of blocks in program, and then how can I identify the second block from that program? Means if I give n2 means which is the second block of that respective program. Likewise I assign the number with the n code, which is called as sequence number. And then G code. G code always known as preparatory word, and also it is called as preparatory function. This G code communicate device to prepare the MCU. What MCU prepared? G code indicates that a given control functions such as G01 means the G code represent linear interpolation within the machine axis motion, which is called as G code. So preparatory function gives the instruction about tool interpolation and tool movement on the work table. And then the X, Y and Z codes. Here you see X, Y and Z codes are available with the program. These are all coordinates. These give the coordinate positions of the tool. And then F code is also available, which is feed rate. The F code specifies the feed in the machining operation. And then another 4 words are also available because the program block is not entered with X, Y, Z. After that also there is lot of data are available. Here S code. S code is represented spindle speed. The S code specifies the cutting speed of the machining process. And then T code, already I told you, T code is represented for tool selection, and the T code specifies which tool is used to be used in the specific operation. It may be a drilling, it may be a turning, it may be a boring, it may be a thread cutting. Likewise the T code specifies which tools comes for next operation. And then M code, the final statement is M code. M2 is available. The M code is called as miscellaneous function. This M code is used to designate a particular mode of operation for an CNC machine tool. And then in program block there is I, J, K codes are available. I, J, K codes defines the center of circle. So if I, J, K codes specify the center of arc coordinates from starting. After our program completion, you may aware about how do I utilize these codes for generate the program, the machine, how do machine obey. Likewise you may aware. Okay, some G code definition. If I utilize in the program G00 means that G code represents rapid mode. So G00 code commands the machine to move as fast as it can to a specified point. If I give this G0 code means the machine understand rapid moves. Okay, here you see machine home position is available. After that actual path available, which is the destination, so that machine can rapidly move from this machine home position to that respective position, which is G00 always called as rapid traverse. I can give G01 also. What is G01? This command moves the tool in a straight line at a programmed feed rate. So G01 called as linear interpolation. So G01 needs the feed data for actuate the tool spindle from that this initial position. After that there is 02 available, and then G03 also available. What is G02 and what is meant by G03? G02 commands clockwise arcs, as like this diagram, clockwise direction. It rotates on clockwise direction. Based on that, the machine control unit performs G3 commands counterclockwise rotation. The second diagram. So if I utilize the milling cutter, means milling cutter moves clockwise motion, means I can give G02 proprietary function on program, and then I can give G03 if I utilize the code as like the counterclockwise motion, means I can give G03. So arc must exist on a plane and include the coordinates of the arc endpoint and ijk vectors indicating the arc center location. These are happening with this preparatory function, that is G code definition. Other G codes are also available. The G00, which is represented rapid traverse, and also I told you that what is meant by G01, that is linear interpolation. 002 and G03 represented circular interpolation with clockwise and counterclockwise, and then G04 is available, which represented non-model dwell, because at dwell time I represented dwell time. Dwell time means the rest time of tool and the relieving time of tool from the operation. These are all comes under, so called as dwell time. So I utilize non-model command also in that program from G04, and then G21. G21 into 6 means model metric data input. The model may be metric type or inch type. I can represent with these commands. And then G28, which is the non-model the data command, which is known as reference point return. Okay, so that tool retrieve its reference point. And then G42, model tool nose radius compensation right. I will tell you the next class what is tool compensation also. So G42 means tool compensation data, and likewise lot of data are available with this NC program, and you can read G73 non-model pattern repeating, and G74 for non-model peck drilling. Peck drilling means you may insert the drill bit into the hole. After that you may remove the drill bit, and then after that again you may plug into the hole for the drilling operation, which is known as peck drilling, which also we can utilize with we can perform with the CNC machining operation with the program. In G75 used for grooving operation, so that with this G code we can represent the different kind of operations also. Here G81 is represented for deep hole drilling, and G98 for representing feed per minute or feed per revolution. G98 represented feed per minute unit. G99 represent feed per revolution unit. Based on that you may give the feed value on the respective alphabetic number, that is F. Okay, if I give F2 means G98, after that F value I give F2 assigns 2 feet per minute, 2 mm per minute. Likewise it may understand. After that I may give G99 means 2 mm per revolution or 2 inch per revolution. Likewise it may read from the G codes. So likewise lot of informations available with the G code. Now we may move M code. What is M code? Miscellaneous code that are available with the program structure. In the last step there is miscellaneous information available. Here what is M code? I want to tell you some examples. M03. M03 represents clockwise rotation. The direction, the tool direction, rotational direction it represents. So M03 clockwise. M04 represents the counterclockwise rotation of the machine tool. And then M06 also available. What for M06? Which represent tool change with the automatic retraction. So ATC available. If I utilize the automatic tool changer means I utilize this M06 command. From this M06 I can give the dwell time for the operation. After that M30. This is also one of the miscellaneous function. M30 represented for end of program, which means return of to beginning of program. With those things I can give this M30 command. Okay, these are all the miscellaneous samples are available with the program. And then other M codes are also available. M00 program stop, M01 optional stop, M02 end of program, M03 spindle clockwise, which means forward direction rotation. After that M04 spindle reverse, which means counterclockwise rotation. M05 spindle stop, M06 automatic tool change, M08 for coolant on, M09 coolant off. So that I can give the auxiliary function, those are coolant on or off with the miscellaneous code, which is M08 and M09. And also I can give chuck open and chuck close also with this miscellaneous function, and spindle forward, coolant on off. Likewise I can give this miscellaneous functions M13 and M14. Tailstock also, turret also controlled with M25. And then the program, subprogram also I can call with this miscellaneous function. If I give M98 means subprogram call canned cycle. Likewise lot of cycles are available, or those things are called as M98 and M99. Okay, these are all the subprogram things are available with your main program. We can choose the subprogram with the main program with this miscellaneous code. And then next common address, other than G code, M code, other common codes are also available, as like IJK available with our initial block. What are all the further commands, common address codes available other than G and M code means A, B, C, D, F, G, H, I, J, K. Likewise lot of codes available. Here A code is used for rotation about x-axis. B code is used to rotation about y-axis representation, and C code is used to rotation of tool about z-axis, and D cutter diameter compensation offset address. I can tell you with what is meant by cutter compensation with the next presentation. And then F feed rate. G means G code preparatory code. H tool length offset TLO. I arc center, which is x-axis, x vector, also used in drill cycles. J arc center placed with y vector, also used in drill cycles. K arc center with z vector. And M code already I told you miscellaneous code, and N is the sequence number representation, which is also called as block number and sequence number. O program number, every program has its own number. From this program number we can choose the canned cycle program and other cycle programs with the main program. Okay, after that P 12 time, which is the rest time of the tool, which is the stoppage time to further operation of the tool, which is can be represented with the P. And then Q used in drill cycles, and capital R arc radius also used in drill cycles. Capital S is used for representing the spindle speed of the rotation which is RPM. And then T is used for specify the tool number. XYZ is the normal rectangular coordinate system, where X is used for X coordinate, Y coordinate, and Z is Z coordinate. These are all the common address codes that are available for creating the program. After that, it is the program format. Now you are aware about what all the codes are available. Now I tell you what all the program formats are available. Every program is started, so that start program is available, end program is available. Intermittent, there is change tool, move to position, machine contour, how do I change the tool, move to position, drill hole. Likewise, lot of purposes are available with the program format. How can I write the program? Yes, if I want to create the program for some particular turning operation, means I can give the program number with O0001, which is project 1. From this code I can give the program number or program name to the specified program, which is called as project 1. This program is called as project 1. With this O code I can represent the program number. After that I can represent the tool description for operator. So T1.25 end mill. From this the operator choose and fix the end mill cutter on the tool post. After that I can give N1. N1 represents the sequence number, the first block in that safety block to ensure machine is in safe mode. For that I can give the various G codes for that machine. From this the total program ensures the safety. After that the second sequence, second block is N2, T1, N6, which from this I can choose the first tool for respective operation, which is tool number 1. Then N3 code is available, which is represent S. Okay, which is represent, this block is represent S9200. So the tool spindle speed is 9200 RPM, and M3 represent the counterclockwise rotation. Likewise I can represent. After that G54 use fixture offset, and then N5 M8 which is represented with this N5th sequence. So 5th block represents coolant on, and then 6th sequence G00 always represents the rapid movement, and then I can give the X and Y coordinates value. X minus 0.025, Y represents for minus 0.275. From Cartesian coordinates, which can be represented with the third quadrant, so the rapid movement available with this 6th sequence. After that 7th sequence I can represent with G43 Z1 H1. Here the rapid to safe plane is available with the G43 code, and then tool length and offset values given with the Z1 and H1. H1 is concentrated about tool offset compensation, tool length compensation. Z is represented for tool. Okay, and then 8th sequence is at 0.1. So rapid movement available with this block. And then N9 G01 is at minus 0.1. F18 means line. Tool moves in linear manner and cutting depth at 18 inch per minute with the F code. And then N10th, these are all machine contour. The contour protection I will tell you. The program simulation software, with the program simulation software I will tell you and explain how the machine contour available with the continuous path. And then the M5 means spindle off, so that spindle off with this 17th block. From this we can stop the spindle, and also we can change the tool after of the coolant. So now the end mill cutter is changed to drill cutter with T2. With the T code specifies the next tool, which is drill. Okay, and then load the tool with this M6 code. After that drill bit is rotated with 3820 RPM. I can represent it with S code, and then M3 is for clockwise rotation happens with that drill bit machine tool. Likewise I can give the data. And then next, after insertion of new drill bit, I can on the coolant. So I utilize M8. After on the coolant and after fixing the drill bit, I can give the rapid movement of the drill bit on the workpiece materials with the N22 X1 Y1 code. After that the similar operations are followed for the drill hole. Okay, drilled hole I followed G98, G81, Z minus 0.3, I mean 325 or 0.1 F12. Likewise, I give F12 inch per minute of feed rate with that drill bit. After completing this, cancel this drill cycle with G80. Finally, I can move the tool with the rapid position, safe play position with the Z1 code. Finally, I may go for spindle off, coolant off. With this, I can end the program with the M30 code, which is the general program format to operate the machine. These things are available with the generate the program. Okay, now you are aware about what are all the components that are available with the NC part program. Generally, the machine setup is started with the pre-start, which means oiling the machines, the coolant level is correct, or otherwise machine is clean. Likewise, you may perform some operation which are all known as pre-start. After that, start home. How the machine tool positions are initiated, start home. After that, the tool spindle is safer position. After that, you load the tool on that spindle. After that, set tool length offsets, tool length compensation, you give that machine. After that, you clamp the workpiece on work table. From this, you set the fixer offset with the XY plane and the Z plane, and then you may load the program with the CNC machine and then run the program, adjust offset as required. Finally, you may perform the machining operation, you shutting down the machine. These are all the setup procedures available with the CNC machine. So these are all the general concepts that you are aware about before writing the program with the CNC machine. Now you are aware about what are all the blocks, how can I assign the values with the CNC program. Now you are aware about the things associated with how can I write the part programming for operating the CNC machine.